Okay, here we go. So we have A equals, and I like pink. A equals 32 degrees, A equals 17, B equals 11, okay? So all we're simply going to do, if we're going to, the best thing that I always like to do is always draw a triangle. For me, it's just a way to be able to visualize what the triangle is. And it doesn't matter how you label it, ladies and gentlemen. It doesn't matter where your A, B, and C's are. For me personally, I like to be able to just visualize where my side lengths and everything else is. It does not matter where you put everything. Okay? This is, I always draw this exact same triangle, though, every single time. And even sometimes, the triangles are not going to relate. But you guys can at least see this. Now, when applying the rule of sines, the law of sines. Now, obviously, for your whole homework, everything was the law of sines, right? That's all you did was the law of sines. However, you guys can notice that this is a side-side angle. Right? That's what we're given, side-side angle. Does everybody see that? Or angle side-side. So if we have that case, we have to check for our ambiguous case, either having no or two triangles, correct? Now, there was one thing I showed in my videos on Friday that you guys could use. But in reality, you don't really have to do that. The best thing I would do is let's just solve for our missing side length. So if we have A and A, well, then I know that's going to be one of my ratios I'm going to want to use, right? So A over, that's A equals over the sine of A. Now, what would I want to set that equal to? What other information do I have? I have B and then over sine of B. Does everybody see? I don't have angle C nor side length C, so I wouldn't use that ratio of C over sine of C. Does everybody see that? Yes? So now I just plug in the information that I'm being provided. A is 17. Angle A is 32 degrees. And B is 11. Now, you can apply cross multiplication, whatever makes sense to you. You need to solve for B. The main important thing is you need to multiply by sine of B on both sides, and then multiply by reciprocal. So you guys should know that sine of B is going to equal 11 times the sine of 32 degrees divided by 17. All right, I'm just not going to show all the math because you guys should be able to get to that point on your own. Is everybody OK with getting to that point? Apply cross multiplication if you want to. Cross multiply, then divide by 11. Wait a minute. Yes, divide by 17, sorry. Yeah. Is everybody OK with getting to this point? So now, in your calculator, make sure your mode is again in degree mode. You simply can just type this in, do 11 times the sine of 32, and then divide that by 17. And what you get is 0.342888937. Now, I really do not want you guys to write this down because I don't want you to round your answer. Because this is an irrational number. So what I do, to find B, I do sine inverse of my answer. So I just leave that number in the calculator, and I just do sine inverse, and I do of, you have to use the second, answer. So therefore, I get B equals 20. And if I was going to round this just to the whole number, I'd get 20 degrees. And that's approximate, because I'm rounding. OK? Now, this is a possible ambiguous case, right? Correct? Possible. Side-side angle. Anytime there's side-side angle, it's a possible ambiguous case. Correct? So what I need to do is check B prime. So remember, when we talked about this, remember, when you guys are looking at the sine of an angle, you have two angles, right? You have the acute angle and you have the obtuse angle. Correct? The sine of these two angles have the same y. Do you guys agree with me that these 2 points have the same y coordinates? Mm-hmm. Right? These two angles have the same y coordinates. So therefore, I need to check for this. So I do 180 minus 20 degrees, and that gives me 160 degrees is B prime. Could B be B prime? Could I do 160 right here instead of B? Could I have two cases? Why not? Why couldn't I do? Because it'd be 192, right? You can't have 32 here and 160 here, right? So therefore, B prime does not work. Okay? So therefore, there's only one case The only case is when b equals 20 degrees. So if A is 32 degrees, B can only be 20 degrees. All right? What if B was like 40 and then B prime was 140? Could you do that? Yeah, you could do that, right? But B is 20, so therefore B prime 160 doesn't work. So therefore, if that's A and that's B, therefore C is simply just going to be 180 degrees minus 32 degrees minus 20 degrees, which is 1. That'd be 52, so it'd be 28. 128 degrees? Yes? No? Sounds good? Mm-hmm. So now that we know what C is, which is 128, now we just need to do law of sines again. Now again, I really don't want to use my law of sines with my value of B of 20 degrees because remember I rounded that, correct? I approximated. So therefore, I'm going to use, again, I'm going to use A and sine of A. So I'll do A over sine of A is equal to C over the sine of C. Well, we already know what A and sine of A are, or A and angle A. That's the same as right here. So that's going to be 17 and 32. And C is now 128 degrees. So now we just cross multiply. And when we cross multiply, we have C is equal to 17 times the sine of 128 all over the sine of 32 degrees. So then we go back to our calculator. And we basically just do 17 times the sine of 128. And then divide that by the sine of 32. And we get 25.279. If we're just going to round this to whole numbers, that'd be about 25. Right, 25, right? Yeah, 25. Right, so I'm just going to round that to a whole number for this problem. And does that kind of make sense? Should my longest side length, Aaron, correspond to my largest angle? What happened?
They couldn't see, so I moved it.
Oh, it's OK. I'll move that over that. But does that make sense?
Mm-hmm.
Did you just do that, or was that for like the whole video?
No, I just did it.
Oh, that's OK.
They told me